Tom Kelly and I'm the Director of Operations at Ionic Technologies. Ionic Technologies is a world-leading business looking to establish rare earth recovery via magnet recycling. And I'm stood here today in Belfast Harbour Estate in front of wind turbine operation, installation and maintenance works that's happening here on the Harbour Estate. So to my left you can see the buildings where a number of wind turbines are currently being assembled and maintained, and then to my right you can see some of the blades which stick out on the Belfast skyline.
Very good. And so we're only about 200 metres away from your building, where we've had a little tour around the shop floor, as it were. How are things going over there?
Very good, thanks. Yes, no, all good. We're producing NdPr oxide at the moment from a batch of wind turbine magnets, and we've been developing our technology even further to establish the heavy rare earth circuit, which is separating dysprosium and terbium.
Right, and lots of interest as well. Now we're sitting here, as you say, in the Belfast Harbour, effectively, and we've got this massive industrial estate here. These guys are going to be interested in what you're producing for sure, but there's a kind of ecosystem building up here as well.
That's correct, yeah. So the Northern Ireland Maritime and Offshore Network's been established in Belfast Harbour. So within 150 nautical miles of Belfast, there's around about 8.7 gigawatts of installed offshore wind capacity.
Yep.
So a whole ecosystem infrastructure is building up around the area in order to accommodate all the various logistics that are associated with that. So we're standing right outside a deep water dock, which has been specifically designed to enable activity associated with wind turbine installation and decommissioning. So within our network here locally, there are businesses that are recycling other components with the wind turbines, but obviously our interest is the magnets. So the magnets represent something like 1% of the mass of a wind turbine, but something like 45% of the value currently.
Wow. Okay. And you're obviously it's kind of early days, but you're kind of moving through to this kind of almost this demo stage where there's lots of interest from around the world, quite frankly, for what you've got. Funding, though, it always comes back to funding. You're working quite heavily with a few kind of UK departments, so can you just talk us through who's involved and what are they looking for from you?
Yeah, so we've had great support from UK government for the development of the technology, so be that via the Advanced Propulsion Centre, whose interests obviously the automotive sector, but also Innovate UK, who have specifically targeted rare earths as the group of critical minerals to enable and develop supply chains within the UK for resilience, but also to create a recycling industry. In terms of the Advanced Propulsion Centre, they've supported us through the development of the demonstration plan, so to get to that demo scale capacity, and they've done that through a series of funding interventions, and we've delivered for them in terms of a successful project at the demo plant. So we now have a demonstrator capable of processing 30 tonnes per annum of magnets to produce around 10 tonnes per annum of rare earth oxides.
Right.
And then the work we've done with Innovate UK, we've received quite a bit of funding from them for specific projects to, first of all, demonstrate the world's first rare earth permanent magnet produced with 100% recycled rare earths, which are high specification, high purity. And we're doing that in collaboration with Less Common Metals, who are an alloy manufacturer, and Ford, who have a large processing facility in Halewood in the northwest of England.
Right, and so for the UK, obviously, like most governments, critical minerals, very, very important, becoming more and more important, and they're paying a lot more attention. But what's the problem that you're potentially solving for the UK as a whole, and maybe even Europe?
Yeah, so the resilience around supply chains of critical minerals is absolutely essential. So if you look at the automotive sector in the UK as an example, it underpins something like 800,000 jobs, right? And in the period between now and 2035, the UK government has a target, so within the next decade, to decarbonise all vehicles, basically. And in order to do that, they need to support the entire supply chain right through from resources to manufacturing. So, in our case, we support that because we're able to provide an absolutely critical component part of the picture with respect to magnet manufacturing, and magnets are essential for EV motors. And our work with Ford is enabling and demonstrating a supply chain is possible within the UK. So in order to support that, the Automotive Transformation Fund has existed, and that's been administered by APC, Advanced Propulsion Centre. Moving forward into the next 5 years, they're going to be rolling out a series of measures via Auto 2030 to further support the development of sustainable supply chains within the EV sector. And we anticipate working with them further on this to further progress our technology and really start to support and underpin that EV sector by provision of critical minerals.
Right, and what's the end game for you guys here? Obviously, we've seen some rendering of a new building potentially that you'll be commissioning soon at some point. What do you get out of being here? Why is this the best place for you as a company?
Yeah, so obviously our journey to get to this point has happened in Belfast. You know, it's a Belfast story up until now. The technology that we have was developed at Queen's University over a number of years, and then obviously with Ionic Rare Earths coming in and taking the business on in 2022, the technology has progressed rapidly. We've employed a team of 27 people, and obviously where we've got to now is demonstration scale, and we want to commercialize the technology. And really at this moment in time, there are a few places better to do that than Belfast. There are a number of reasons for that. We're joining a group of net zero businesses that have successfully commercialised and developed technology here. It's a very IP rich area in terms of Belfast Harbour estate. Belfast Harbour itself is nurturing that ecosystem to encourage a business to locate here in order to build IP and commercialise technology. In terms of our reasons for being here, we see the access to both UK and European Union markets as a really useful attribute for the business to benefit from. Obviously our relationship with Queen's is well established and continues to provide for us in terms of talent. So the building that we have just a few hundred metres down the road is home to a number of really smart and talented individuals from the Chemistry and Chemical Engineering School who have graduated through the university and brought their skills and knowledge through to the technology and applied it efficiently and effectively in our process. And then in terms of local government support, we're very well within, as you've already alluded to, a lot of the goals and objectives for government growth, and particularly in the region. So for Belfast particularly, it represents a really attractive case to locate here because of that government support, and the recently announced innovation zone is somewhere where you want to locate.
And it's quite clear to us, having walked around the factory, that this is way beyond science experiments, way beyond a thought or an idea. You're close to that kind of commercialization component, but what you need for that is people testing your product, testing your processes, and getting something out of it at their end. So has there been much engagement from that point of view?
Yeah, so we've lots of supply chain interest. Obviously what we're looking to do is advanced, so in terms of the need for recycling technology in the UK and Europe, it's got to come. There are targets for that, particularly in the European Union, with a 25% requirement for recycled source material from recycled manufacturing, and we're able to basically deliver on that. So in terms of supply chain partners, we get lots of interest in terms of who we can supply rare earth oxide into, where it can go, what it can be used in. But we're proving via our process that the quality of the product that we make is very, very good. So it's up there in terms of compositional analysis when compared to virgin material, and it can be used in many high specification applications. So magnet manufacturers particularly have a lot of interest in what we're doing, as does alloy manufacturers, and as I alluded to earlier, we're working officially in collaboration with Less Common Metals and Ford on that complete supply chain in one funded project. But also beyond that, we're working with a number of magnet manufacturers, and then from a feedstock perspective as well, we're working with a number of partners who can provide that in. So security around material coming into the plant is so important. At this scale, at the demonstration scale, we get lots of material to test and trial with our process. It's very robust and it's coped with that. At the commercial scale, obviously, we need to secure feedstock agreements to ensure that we keep material coming in. But as you can see behind us, there should be no shortage of that in Belfast because of the high volume of material that's coming in and out of the port. I
guess the nervousness for people like the guys behind us is where they're going to get this from that conforms to, I guess, some of the regulations around this 25% number. Currently, that number is at what?
Well, in global terms, recycling represents around 1%.
Right. So there's a bit of way to go.
Yep.
And I guess what you're hoping is first mover advantage will going to help you, stay ahead, get ahead, and create a kind of defensible business model for you. What's your sort of time frame? How do you kind of look out at this, hitting this 2030 target? Are we going to be able to do it?
So from an Ionic Technologies perspective, we want to move quicker than that. We see an opportunity here. We see feedstock. We see material that could be recycled domestically being sent abroad to be processed, which, given the fact that there is a real criticality around this material, is not a comfortable position for anyone. So we want to commercialise the technology in the next 2 years, and we believe that's possible. And one of the reasons why it is possible is because our process is simple to scale. We don't need any of the complexities of refinery or mining processes that takes the time. In our case, recycling is something that can be delivered very quickly. I mean, whilst we are a scale, an order of magnitude lower in the demonstration plant, we've managed to deliver that in a period of around 12 to 18 months. And for the commercial scale plant, a lot of the equipment would be very replicable. It would be the same equipment on a slightly bigger scale.
Is the 25% number achievable by 2030?
From an Ionic Technologies perspective, we believe we can move quickly to meet that. So we are intending to commercialise the technology within around 2 years. And we believe that's possible because the process that we have is scalable. We're not talking about a big jump in terms of order of magnitude from the demonstration plant compared to mining and refining when that's scaled up. Everything is here for us to do it. And the feedstock that we need to recycle, at the moment, given the fact that that contains absolutely critical material, for it to be exported at the moment is something that we want to prevent the practice of as quickly as possible. So that material is available and we can recycle it now. The process can be delivered quickly. We've proven that with the demonstration plant, which has gone from design through to commissioning and operation in a space of about 12 to 18 months. So at commercial scale, we will have obviously added elements of complexity, but the core process is the same. So we believe that we can make our contribution to that target rapidly.